I cannot see the person that raises their hand, so Raphael will manage that. Will manage that part.
Absolutely.
Good.
Okay, so thank you, and Thomas, the floor is yours.
Okay, thank you. A small word of introduction. So the name is Thomas Weckman. I'm working for a resin company, AOC. I'm within EuCIA. I'm in the working group sustainability. And as Raphael mentioned, I've been closely involved in this specific project. We have worked with an external company to evaluate the CO2 impact of cement co-processing, and in particular, the treatment of end-of-life composite materials in cement co-processing. And what I'm going to do is to give you a little bit of background and then talk through some of the results, as well as some of the assumptions and sensitivity analysis that we've done. And at the end, I will provide you with the contact details of Raphael. If you have further questions, if you would like the full report, or even input files that you can use for a life cycle analysis, that is possible. And Raphael will do the coordination of that communication. So let me see if this works. 2 words on EuCIA. EuCIA is the European Composites Industry Association, representing the different key stakeholders in the composites supply chain, the value chain, and really with as a mission statement to support the growth of the composites industry and make sure that it can flourish, and making sure that some of the key challenges that arise are addressed. And one of those key challenges is composites recycling. And really, we've worked a lot in the last few years to better clarify the situation and work on some of the aspects of composites recycling, as you will see. EuCIA consists of a large number of national composites associations, as you can see in different countries in Europe, different industry sectors, from resins to some components, pultruded components, SMC, BMC materials. And there's also some sponsors and partners that working with EuCIA intensively. So altogether, how we'd like to present you the results of this study, which have been done with a number of associations. I will come back to that in a minute. As you know, composites, they are made to last. If you compare with conventional plastics, it's also a plastic material, of course, but these materials are they use typically for 5, 10, 100 years, depending on the specific application. So car trucks, it's more 10 to 15 years, wind turbines 20, I think it's getting closer to 30 years now, boats 30, 50, sometimes even longer, and bridges and infrastructure components, it can be even up to 100 years. And at the end of their life, they need to be recycled. Perhaps it's better to say end of use, because in many cases, the composites parts, they last longer than their application. So the boats typically are sold or replaced when the interior is not nice anymore, but the composite structure, the composite components, they survive the application. And that's also sometimes a bit more challenging when you want to recycle these materials. If we look at this life cycle, as I said, this is 5 to 100 years of use phase. In many cases, through repair, it is possible to extend the life of a composite part, but at some point in time, there is the end of use. And then something has to happen with that material. In the current day, at present, we do see that still there is a fair amount of material being incinerated. There is still some material in landfill even, but really that is something that we would like to avoid, as there are some good technologies already available and are in development for recycling those materials. And one technology, which I think is closest to the commercial reality and really technically has been proven, is the reprocessing into cement. And that will be the focus of my discussion today, which we would consider an open loop recycling. And so we take the material out of the composite circle and put it into a different one, the concrete and cement. There is other technologies. Mechanical recycling is being done and practiced in different applications. Thermochemical recycling, like pyrolysis, solvolysis, and there's different technologies with mechanical oscillation to separate fiber and matrix. Those are all in development and scale up. And the idea is that those materials would help to increase the level of circularity for recycling composite materials. And I think those technologies, they will evolve over the coming years. We wanted to work first on an application or the recycling technology that is there, and has already been proven, I would say, in sizable volumes. But what was lacking was the data behind and the numbers behind. Cement co-processing is a technology that we believe will help to pave the way for other technologies. The big challenge, and I think this is a discussion that we've had with multiple stakeholders in the supply chain, is not necessarily what is the right technology for recycling composite materials, but it's really bringing together the volumes and making sure that the upfront collection and the separation of materials is working well, and so that these materials can be processed in the right way. And I think that's also where we see our focus is going more and more. It's okay, while these technologies are under development, and while there is technologies that are there already at industrial scale, like cement co-processing, the work that has to be done before in the collection and making sure that this works at European level is going to get more attention in the coming years. When we talk about cement co-processing, just to be very clear on what it means, it does not mean that we're going to take the fibers and going to reinforce concrete. That's not co-processing. Co-processing is taking the material, the composite material, to grind it and to use the full composition for making the cement. The material is heated up to 1400 degrees, which means that the fiber shape is lost and that the ingredients in the material are going to be used as raw materials for making cement, up to 70% of the composite waste, depending on the specific composite part composition. And it will replace conventional raw materials like limestone, calcium carbonate, bauxite, the aluminium oxide, silicium oxide in cement manufacturing. And those are typically the raw materials used for making cement clinker, and afterwards that clinker is ground and is then mixed with gypsum, I understand, and sand to make the ultimate cement that we can buy or that is used for making houses, building houses and buildings. 30% of the composite waste, the matrix, is burned, and that is replacing fossil energy sources, for instance, coal. But there are also different sources like lignite, brown coal, and petcoke, which is a heavy oil fraction. And we all see that by doing that, it is possible to save CO2 in a nice way. Again, so it's not reinforcement of concrete; it's really melting the material and using it as a raw material for making the cement. And the technology has been there for quite a while. I think it's been practiced for the last 20 years. In Germany, there has been a company, well, the company still exists, EoL, but that company has been processing approximately 10 to 15 kilotons per year of recycled materials into cement. They have collected it, ground it, and mixed it with some other waste materials to have some constant calorific value and then shipped it to the nearby plant from Holcim. And that plant has been processing this into cement and worked pretty well. Unfortunately, that company has discontinued this activity because of their energy prices, and they focused on different things. There are some new companies setting up. There are some new companies installing grinding equipment, and we hope that they will become available for absorbing a fair amount of composite waste. In Finland, the Kimura project has started in 2021-2022, which originally was a government-sponsored supply chain collaboration, but now that it really has converted into a full commercial operation. There is a waste company that is collecting the material in different parts of Finland and is shipping it to Fincementi for production into cement. And it's right now it's a smaller scale, not as big as Neola, but we are confident that it will nicely grow and it will operate. And the idea is that we will find more places in Europe where customers that make components or companies, stakeholders that take back end-of-life components can bring the composite waste and it can be processed. But that is the challenge actually of composite materials, is that compared to a lot of other waste streams, the volumes are relatively small, which does not mean that we do not take care of it, but it's relatively small. So the logistics are sometimes a bit more complicated, and it needs a bit of support. And I'll come back to that at the end of my presentation. When we talk about co-processing, there are several industry associations, and when we sat together to talk about the technology, we realized that the numbers were missing, and we thought, hey, we need really to work on collecting some information on the process and to collect some good data, to do some good calculations, so we can more or less define or predict what is the CO2 savings possible with this technology. And you can see there are companies like Glass Fiber Europe making the fibers, TechFab Europe, the textiles, resin manufacturers, saturated polyester and vinyl esters, epoxy resins. There's companies that make different intermediates like the European Alliance for SMC-BMC, as well as end users of composite components like Wind Europe and EBI, European Boating Industry, in combination with Sembureau, the manufacturers of cement. We've also co-sponsored this study, and EuCIA, as we hear today, we really would like to combine this information and present to you, because we believe it is important for the composites industry that this information is becoming available and is also going to be used in different life cycle analysis. The LCA was done by a company called SGS Intron. They are a consultancy company with a broad LCA experience, particularly in the field of cement manufacturing operations. They've been doing a lot of analysis for different cement companies, including the use of alternative fuels. And so we thought that they would be a good company. They have used the ISO 14044 standard and different details on the specifics of the study. I'm not going to present here today, but it is available in the report if you would like to read and if you would like to have more information. They've used CIMAPRO software. At that point, when they collected the information, it came from EcoInvent 3.8. That's already new information, but at some point they had to decide, okay, which information to use. And then the study was peer-reviewed by another company, NIBE, and they have confirmed that the study was accurate and correct and following this ISO standard. So we are quite confident that the results that have been generated are representative and really are good for doing this kind of analysis. If we look at the results, you can see on in this graph that if you use glass reinforced composite materials in making cement, it is possible to save CO2. The number is 330 on average, and when I say on average, it is the average of 3 different material profiles. I'll come back to that in a minute. And it's a fair amount of CO2 savings per ton of composite waste. If you compare that with the reference for composite waste treatment, which we believe is incineration with energy recovery, that process, it generates plus 500 kilograms of CO2 per 1 ton of waste, because you have to burn the material in the waste incineration plant. So the difference between the two is 830. That's what we see is a nice difference. What we would save. Again, the 500 kilograms is also the average between. It's the average for the different waste profiles. I'll come back to that in a minute. In addition to the savings on CO2, the greenhouse warming potential, there's also a nice savings in resources, but people would say the ADP fossil. There's about 12 gigajoules of fossil resources that can be saved. And so our conclusion is cement co-processing makes sense for treating end-of-life composite waste because of these calculations, because of these results. And these numbers, they are assuming that composite waste is used instead of coal, and I will explain a little bit later about the different fossil fuels and looking at the sensitivity analysis for different fossil fuels. But I'll come back to that in a minute. The numbers that you see here have been based on different material profiles. We thought that for doing this calculation, it makes sense to look at different material systems that are being used in the composites industry. This is obviously not 100% covering everything, and there are obviously some variations in compositions that you or your customers may use. But we try to separate between a material typical for hand layup, spray up, 50-50 glass fiber and resin, a material used in infusion pultrusion, more 70-30 glass fiber resin, and a material typical for SMC, glass fiber resin, both in the 20%, so the 20 to 30% range, and a fair amount of calcium carbonate filler. The big difference here is that the calcium carbonate filler in SMC has to be converted into calcium oxide in the manufacturing process of the cement. And the typical process of cement manufacturing, calcium carbonate limestone is converted into calcium oxide, which is a key component of the cement clinker. And that in that reaction, CO2 is released, which is one of the sources of CO2, besides the CO2 that comes from burning the fuel in that process. You can see in these different profiles that we use a different resin mix. And this is just our best assumption on what is the right material to use. And there's information used from AVK, which have the German Association of Composites Manufacturing Companies. They have published a market report on the size of the market, and based on that, we have more or less assigned a certain volume market share, and therefore we in making an average number for the market, we've used this weighted average for these different material systems. But if I go to the individual materials, you can see there is a reduced CO2 savings. There's a reduced global warming potential. So CO2 savings confirmed for all these different material profiles. And that is a little bit more for the material which contains the higher level of resin. It is a little bit less for the SMC, which contains the calcium carbonate that is associated with that conversion of calcium carbonate that I was talking about. So if you take the weighted average of those three, you end up with the 330 number that we've used in the picture before. Besides global warming potential, there's also different LCA indicators. We have multiple indicators in the report. This is just a small summary of the key ones that are often used to describe different processes. And I don't want to. It's not. We don't have all of them here, but just to give you a flavor, we believe that across the board it does make sense to use composite waste in the co-processing, because also for the other indicators there's that reductions possible, so that's positive, and it only reinforces the situation. It only reinforces our findings that it makes sense. Important is that we have used coal and we've used fossil resources as the reference material. If you look at the European mix of fuels that is used for making cement, the intention of the cement manufacturing companies is to increase the use of alternative fuels as much as possible, because they would like to avoid the use of fossil-based fuels. But still, in 2021, the number was 53% is alternative fuel, 47% is still fossil fuel. This number may have been reduced a little bit, but still it's a lot of fossil fuels being used, and therefore the companies, if they use glass reinforced composite materials, they would replace fossil-based fuels, and therefore we have taken those as a reference for this calculation. And using composite waste can clearly help to increase use of alternative fuels. Some plants, some cement operations, they will be closer to the 100%. Some of them are much lower. So depending on the specific situation, it makes more or less sense to use these materials. But there's still a lot of capacity in the market for using these composite waste materials. If you do a quick sensitivity analysis between coal with petcoke and lignite, you see there are differences. Petcoke has a bit more energy content, and therefore you need less for heating the cement, the cement operation, the cement oven. But across the board, the savings are confirmed, and it is possible to reduce the CO2 emissions of cement operation. And in this case, we've used the specific profile, the GF50, the 50/50 glass resin as the baseline for this specific sensitivity analysis. And also here, it is possible to see that also in the other output categories there is savings possible, and it looks pretty positive. So that's all nice. So what we have done is we have published last month a summary of the report. which is available on many of the websites. If you like to go to the EuCIA website, and you can download it there. We have published a summary with the key slides from this presentation, which you can get there. But also what we have available, if you would like, is the full report. And if you would like to get a copy, you can contact Raphaël Pleinen through this email address, and you can receive it. And really what we like to do is that you take the information and make your own LCAs. And we really would like to make this information available for the industry, to make sure that we will help to advance the adoption of composites recycling as a technology. Really, that we also help to bring together different volumes of composite waste, so that we can start up to increase the adoption of any composites recycling technology, for ultimately for further promoting composites used in different applications. What we've done in the before I go to the next slide, what we have done in the last half year, 3/4 of a year, is to have some dialogues with the European Commission on composites recycling. We went there and talked about composites recycling general, what is the state of the technology, which technologies are further developed in terms of technology and commercial acceptance, and really trying to find the good way to have these technologies adopted, and really to increase the level of understanding with the European Commission about what are the technologies available for composites recycling. And I think the feedback was that they really appreciate the fact that we came forward and that we take that initiative. At the same time, they said, well, we do see that composites technologies, materials volumes are relatively small compared to plastics. If you look at the volumes, we're talking about 1-2% of the total volume of plastics, and compared to the total volume of total waste in Europe, plastics is about 1 or 2%. So composite waste is relatively small compared to the rest of the different types of waste. And therefore we've asked the European Commission to help us with legislation, and to help to facilitate the collection of the composite waste, and also to facilitate the collection of the waste across borders, which is not always easy. We asked first to confirm that this technology, co-processing technology, is recognized as recycling. And at first, that is the 70%, of course, of the material is definitely recycled. And we would like to have that confirmed in some of the directive and the standards. In addition to that, we've asked to revise the list of waste, to create dedicated waste codes, so that really we can combine the volumes and we can transport the materials across the borders, and to work on specific legislation that facilitates this collection. I don't want to go into the detail today of which exact paragraph or which exact directive has to be changed, but this is something that we are discussing with the European Commission, and really we've asked them for support to make this whole process work. So what you've seen here, and what we'd like to explain and provide more information around, is that composites are definitely circular. They can be recycled today already in co-processing, which makes sense in terms of CO2 savings. And we believe that the co-processing is paving the way for other technologies, but the collection and bringing together the volumes around Europe, making sure it ends up in the right place for the proper processing, into different recycling technologies. That's really where the attention has to be. And that's where with these different associations working together, moving forward, that's where a lot of our attention will be. And while we will support, of course, the different recycling technology developments. That's very clear. So this is the summary of the discussion today. And let me see. Yeah, so I have given here, or we give here our contact details for follow-up questions. But I think this is already giving a good, giving you a good insight of the work that has been done over the past year. And yeah, we feel very happy that it was confirmed that CO2 savings are possible. We feel confident that the analysis is done in the right way, and also with the peer review that the quality of that analysis has been confirmed. And we invite you to use the information, and also to work with the key players in the chain to bring together the volume and really make it happen. So that concludes my slides. I'm happy to take questions.
Thank you very much, Thomas. No, it's great. So I take the first question, which is Kyle. Go ahead.
Yeah, thanks a lot for that. It's really interesting. So Kyle Pender, I'm from National Composites Centre. Yeah, just a quick question. How do you think practically the glass fibre composite waste will be integrated like into the cement kiln? Do you think it's going to be mixed with other kind of waste fuels, like SRF or refuse derived fuel, or just kind of shredded, ground up and directly integrated into the cement kiln?
Well, I give you my view, but here I'm not the expert. I think that the way it has been working in the past, and now we've been talking for NEOA, is that the material is ground into small pieces. It's about 1 centimeter, 2 centimeter size approximately. Then, based on the composition of the specific composite waste that has been processed, it has been mixed with shredded plastic waste. So that the plastic waste that cannot be recycled, or paper waste that cannot be recycled, in order to have some kind of constant calorific value. And that fraction is then sent to the cement processing operation. The way I understand that the cement companies work is that they have, depending on the availability of the different fuels, they can switch and they can make different mixes, and depending on well, let's say if there is more availability of composite waste in 1 month compared to a little bit more availability of tires in another month, they can modify their mix and they can optimize for their specific application.
Can I just ask a quick follow-up on that point?
I'm sorry?
Can I just ask a quick follow-up, additional question on that point? Yeah. Because if it is mixed into other fuels, which potentially have a bio content, my concern would be that the GFRP maybe doesn't actually displace fossil fuels. Perhaps it actually displaces fuels which have a bio content. And then in that case, you might see a flip in terms of the benefits from the CO2 perspective. That would be my only concern, is around the practicalities and whether you are displacing fossil fuels or not.
I understand your question, but I think that we've had a lot of discussion about this actually, because this is are we replacing coal, or are we replacing different fuels that are alternative fuels? And the conclusion is we are replacing coal and we are replacing fossil-based materials. So if a plant is running on 100% alternative fuels, yeah, okay, you would not replace all the alternative fuels by this one. But if a plant is using 70% coal, of course it makes sense to use these materials. That's the conclusion, and that's also why I had my slide that's close to 50% of the volume in Europe, of the fuels in Europe used, is still fossil based, and that's the target, and that's why we've done that calculation. Well, the question is a valid question. Thanks for asking. Yeah.
Thank you.
Next question.
Giorgio, you're the next. Go ahead, Giorgio.
Hello, I'm Giorgio Bettetto from GS Recycling of Italy. First, I would like to compliment for the really excellent work done. I think that is really, really, really important, mostly because effectively open new way. I really appreciate also the part regarding the rules and the regulation. That's currently what makes really difficult any kind of over national transport. I would like also to add some two notes. One is that this may become a really interesting business to do. Also because in reality to make the composite waste an important, an interesting waste, an interesting feedstock for cement kilns, it will require some works on. I have experience in the recycling and in waste management, and so I know, for example, in Italy and Southern Europe, the waste derived fuel market is important. What the customers want are a constant product with constant performance, and they would like to change at least as little as possible. So this will be so the composite waste need to be shredded, need to be particle reduced as Thomas said. Need also to be as most as possible.
Non sento niente.
Sorry, do you hear me?
Yes, we do. Go ahead.
Yes.
Please mute.
Well, what it need also is to take away and separate the core material or the reinforcing material, like in particular all the kind of foams or rigid foams, and also the balsa wood, because from we had partners that we have customers that were with work that doesn't accept particularly the core material because the PVC content could make really problem in during the incineration. On the other side, this make also a really interesting output for any kind of powder and dust waste that is always present in the composite fabrication. From SMC, from shipbuilding, you will find everywhere dust. Dust may be, I think, a really good feedstock to also to be considered that there are already several companies that make dust from plastic waste as additive for waste delivered fuel. So this isn't. We are also in the Refresh project. We are also working with a shredding company and so on. So I think that also this Refresh project may help in giving advice on how to prepare, how to process the material for this. I am convinced that may be a big business in the future, mostly if the rules are clear and the norms becomes stable and not ever changing. And so it's something I think that will be really, really could make big quantities and big advantage for environment and for enterprise too. Thanks.
Thank you very much, Giorgio. Thank you very much for perhaps one small comment on that is we did have discussions with the Cement Manufacturing Association and CEM Bureau, and we asked the question, actually in all the discussions, that questions were asked, like, what is the sensitivity for specific ingredients in the composite waste? For instance, carbon fiber. Can carbon fiber be processed? Can PVC be processed? And I think that the comment was that in small quantities, even carbon fiber should be possible. But when you have carbon fiber composite components, those are typically components. The fibers typically have such a large residual commercial value that you really want to take them out and process them in a separate way and not in a cement co-processing operation. But that's a different reason or a different technology that people will use for those materials. I suggest we go to the next question, Stella.
Thank you very much, Thomas. It's fantastic work. Yeah, I suppose trouble is I've written down about 7 questions, but yeah, to pick out the key ones. Well, one statement, I think it's really important, as you've said, to value the mineral content here. And people say it's not closed loop recycling, but when you think that the minerals that go into glass fiber manufacture are actually very similar to the minerals that go into cement manufacture, but the cement process is much more tolerant. And whereas to put it back into glass fiber manufacture, it seems from the research that I've seen that you have to do a pyrolysis first to remove all the organics before you can put it back in. So it makes more sense to put it into cement. If we're burning the resin, it would be really nice if we could move to bio-based resins, so we're not burning a fossil source. But I suppose my overall thinking is this has to be a temporary solution because cement processing will and is moving away from coal. But temporary is still quite a few years yet. So we should accelerate it because at the same time, it will bring together the waste streams and allow us to then divert to more suitable recycling processes as they emerge.
Very correct. That's also what we've been discussing. And I think that of course, if the cement operation will be at 100% alternative fuels, and then that there's less opening for glass reinforced composites. But for the time being, for the foreseeable future, that there's still a lot of, say, capacity for these for the cement operation to take materials. I've been looking quite a bit to pyrolysis process. I know a few things going on and 3 different projects with different companies and collaborations, industry collaborations. It is true. If you separate the fiber and the matrix, you can end up with different waste streams that if they are clean, it's easier, I should say, to reuse them. Rather than when they are still contaminated. And there are some promising developments I've seen and some very nice processes, but they're still in scale-up mode. And as long as those are in scale-up mode, cement co-processing could take a fair amount of volume. But again, the challenge that we've seen is okay. There's of course, there is the technology development and the recycling technology and the process development, but the collection is where it's that's where the big challenge is for the moment.
Yeah, but even though they're in scale-up mode, I think all of them except for the mechanical recycling still end up burning the resin as fuel in one way or another. I know in solvolysis, in theory, you can.
Not necessarily.
Not necessarily. Okay. Okay.
No. I've seen processes where something up to 80% of the organics is saved. Yeah. But that's
yes. Well, yeah. I've seen that in research, but to commercialize it seems very difficult. Lots of solvolysis projects.
Let's see.
Where Yeah, well, I hope it works. I hope it works.
Thanks for your comments. Thank you very much.
Yeah.
And again, if you have any more detailed questions on specific questions on the details of the study, Raphael and I'm happy to take some of the questions afterwards. So that's no problem.
We have a question from Brefni. So go ahead, Brefni.
Yes. Yes. Hello. Can you hear me?
Yes.
Yes.
Okay. Yes. Brefni Bowles. I'm in France. I work for EuCIA, which is a French family-owned cement company.
Mm-hmm.
And so we are in charge of the sourcing of alternative and raw materials for cement factories in France.
Okay.
We recently met with Raphael.
Okay.
Yeah, so great. Thank you very much for this presentation. It's very clear. For us from the inside, the cement industry, we're not surprised with the conclusions because, of course, we know that all the alternative fuels we use since over 30, 40 years, it can be waste tires, animal meal, plastics. Mm-hmm. Of course, it's for the reduction of the emissions of CO2. We know this is going to reduce our consumption of fossil fuels. In the case of the composite materials, we're halfway through between alternative fuels and alternative raw materials. As you said, the ash content is very high, 50, 70, even over 70% content of materials or minerals. So what I wanted to say is that in the conclusions, I see that it's mainly focused on the alternative fuel side. And I think we should insist just as much or even more on the alternative raw material side.
Mm-hmm.
Because some of the composite materials have over 50% of ashes content. So that means it's even more an alternative raw material. So really to emphasis on this recycling in the cement process when you use the waste, this kind of waste. It's in fact the difficulty we encounter if we want to use this waste is the ash content, which is very high, which means that we cannot really consider it as a normal alternative fuel, where we want to have a low ash content. So if we use it in a cement factory, it's really not as much to replace the fuel, because we could use SRF or other waste, as to replace our raw materials.
Thank you very much.
The person before just said it also is that when we have high rates of alternative fuels already, some of our cement factories are close to 100%, or between 80 and 100% alternative fuels. We need to have really high grade alternative fuels to achieve the 100%. That's why it's difficult to achieve it with such a waste. So we have to really think of different ways of introducing it in the kiln. Not so much as a replacement as the fuel, as replacement of the raw materials.
Very good. Thank you very much, Brefni, for explaining. Excellent.
You're welcome.
And thanks. There were on the site, there is a comment on the chat that it would be good to have a survey to know the percentage of alternative fuel used by the different cement kiln in Europe. It might but touch some sensitive information.
Well, the information that I shared on that slide was coming from SEMbureau.
No. Here it's the average, but here the idea on the chat, I remember.
Okay.
Now here as we just said, when we reach 80 to 100% alternative fuel, of course the motivation to use composite waste is lower. So can we focus on the kiln where there is a lower percentage? And of course the average is 53% in Europe, but after that going to cement kiln, individual kiln, maybe it's possible, but we have to look at also in terms of first of all, if people would like to share it, and that's different things. Oops.
Any more questions?
Yeah. So anyway, the presentation of Thomas will be provided to all of the participants, including the link to the record of the presentation. As also Thomas said, if you have any additional comments, questions, we are free to we'll come to handle the questions and trying to answer to all of you. Okay. So, is there any other questions? Okay.
Just one small question. Sorry, Didier Miller from Clarion speaking. Hi everyone. Just a small question. Can we share this presentation in the whole partially, or shall we wait to have some digest to?
That's a public information now, huh? So okay. you can use it as much as you want. Yeah. As Thomas said, that's a solid study done by SGS, plus has been peer reviewed by independent third parties. So and all the information is public. It's part of it. It's on our website, plus the complete background document if you need. So yeah.
Okay.
Go ahead.
Thank you.
Maybe sorry, just another question. Maybe in the LCA, did you compare to the landfill or only a waste incineration?
Actually, we compare to incineration because the landfill is not circular, I would say. We the discussion that we've had with, particularly with the Wind Europe Association and EBI, they specifically are saying that they're publicly saying that they would like to avoid landfill and really start to use recycling and reusing these materials. These are even composite waste is a valuable raw material for making other things, and one of those other things is cement. That's what we talked about today, and it's there are some other things that you can do as we said in the beginning, and so it is really it's all about using the valuable resource.
Also, I put in the conversation a link towards a new ISO standard. I don't know if you heard about it, but it was released recently, I think in April or May. And it gives the method to calculate the recycling rate in the co-processing in cement factories by using the ash content. So that's an interesting document for you.
Thank you very much, and we'll put it in the chat. Okay. Is there any other comments? Okay, so we are perfectly on time. Again, a big thank you, Thomas, for all the study and the presentation today. That's really great, and once again, thank you very much for all of you participating today. And if you need any further informations, you have our contact. Okay.
Thank you.
Thank you very much.
All of you.
Thank you, Raphael, for the organization of the webinar.
Thank you very much.
Thank you. Bye.
The webinar.
Thanks, Mr. President.